how to calculate the z-score in statistics. Perfect for AP Calculus students or CP Calculus or even students who are in college. And I can see you recorded me. I don't know why. So guys, here we go. It's okay, where I recorded before. It didn't say you were vlogging. You vlog too?
Just it just stays on my camera roll.
So you vlog funny stuff then?
Yes.
And you consider me to be a funny in the funny zone, so okay. Alright.
What's your YouTube?
8 hours, yeah. Okay. Hold on guys, I'm coming. Okay, so we are going to be calculating z-scores, and so z-score is another way of saying you're converting your actual score to a standardized score where all the scores will be considered to be normal, where the center of your distribution is going to be 0, and we consider 3 standard deviations above the mean and below the mean. So I'm going to write my 3 here. So with the standard deviation, you need to examine the center as your average or your mean score. So when drawing your bell curve, you add your standard deviation to your right, and you continue adding this. Then when you go into your left, you subtract your standard deviation from the mean, and you keep subtracting. So we have a question right here that says, in your case it will be degrees Celsius, right? So I say a Dutchman height has an average height of 184 centimeters with a standard deviation of 8, and you're supposed to use the 68, the 95, and the 99.7% rule, number 1, to do this. So your center is going to be your mean, and my mean is 184, and your mean should be 77, so write 77. And we're going to be adding our standard deviation as we go to our right. We're going to be subtracting as we go to our left. We consider 3 standard deviations above the mean and below the mean. Reason being because this is where the bulk of your the percentages lies. So even though the area under your curve represents 100%, between 3 standard deviation represents 99.7% of your data. And that's the reason why we established these 3. Okay? So we're going to be adding our standard deviation to our right and subtracting to our left. So this is 184. So we're going to plus 8 to give us, 192? 192. We're going to plus 8 to give us 200. We're going to plus 8 to give us 208. If you're moving to your left, you subtract your standard deviation. So it's going to be 184 minus 8 to give us 176. So 176 over negative 1. 176 minus 8 to give us 168. 168 minus 8 to give us 160. And this is how you represent 3 standard deviations above the mean and below the mean using the 68, the 95, and the 99.7% rule. Did you finish yours? Yeah? Okay, good. Now, you're also asked, so it should be 68. You're also asked to determine which of these represent 2. So you know that between negative 1 and positive 1, I'm going to erase these 8s, is 68% of your data. Between negative 2 and positive 2 represent 95% of your data. Between -3, I'm going to go to the top now, and +3 represents 99.7% of your data. So knowing this, you know that 50% goes here and 50% is above it. Understand that? Alright, so that's 3. So the next question says, what percent of all Dutchmen should be over 200 centimeters in height? In your case, it should be degrees Celsius, right? So look at the number they give you right here and identify it on your graph. So for me, over 200 would be the region that's above 2. It says over 200. So it's a region above 2 standard deviations. So it's all of this region I'm shading right here. And I know that 2 represents 95% of my data, right? Between 2. Are you following that?
Mine just says given an approximation for temperatures as a percentage.
Yeah, I know, but what's the percent? 77. Where would your 77 fall? Give me a second, guys. I'm coming. Give me a minute. Say 77 for your 77 for your mean. 77 for your mean. What was your mean? 77.
Yeah.
What was your standard deviation?
4.
So tell me the numbers you have one above and below.
81, 85, and 89.
Here.
73, 69, and 65.
Okay, what did the question down here ask you for?
Approximation for temperatures as a percentage.
Yeah, what's the number? So you have 3 questions to answer for yours. Alright, so alright, let me do this part, I'm gonna explain yours after. Alright, so here it says above 200, so above 200 will be the region that's above here. But I know that between -2 and +2, that's 95%, right? And if my data should be symmetrical, that means I'm gonna have equal amount on either side. So if I say 100 minus 95 should give me 5% remaining. And that 5% should be everything above 200, everything below this region. See that? Because that's the smallest part of it, above 2. Alright, so if I have 5% remaining, I must share that 5% to the 2 sides. So I'm going to divide this by 2 to give me 2.5. That means 2.5 is above and 2.5 is below. And because your bell curve is a never ending curve, this 2.5 extends on and on and on. But the more you go to 4, 5, 6 standard deviation, the smaller the percentage will be. That's the reason why they only focus on only 3. So the question you have, hold on, let me see if I can add a page and do the question that you are doing. Insert, word, no, page, blank page, control copy, duplicate. Alright. Okay, so here we go. So the question you have, your mean was 77, your standard deviation was 4. I'm going to quickly draw the bell curve and then remember you said the numbers are. So that's 73, that's 69, and that's 65, right? And that's 81, 85, and 89. Alright, so give me the 3 numbers. So what's part 1? Between
73 and 81.
73 and 81. So 73 is right here, and 81 is right here. We know that -1, 2, 3. So the 68, the 95, and the 99.7% rule should help you to understand which of these regions represent 68. So that's your first, between -1 and 1. This one, -2 and 2. This one negative 3 and 3. Get that? So 68 between negative 1 and positive 1. So negative 1, positive 1, the same thing as 73 and 81. You see that? So what percent of the data is that? 68%. So 68% lies between 73 and 81. Also, you know the half of here is 34, half is 34. If you look at it that way. So both of them gives you 68. Next question.
Less than 81.
Less than 81? So less than 81. So if the middle here represents 68%, out of 100, what's left? So calculate subtraction. So 100 minus 68. 32. Thank you. So if it's symmetrical, equal sides should be equal on both sides, right? And so above 1 and above and below 1, negative 1 should be the same number. If it's 32, let's divide this by 2 to see what's the equal amount on either side. 16. That means from negative 1 this way is 16%, and negative 1, the opposite direction, is also 16%. Okay? So if it asks you less than 81, it's asking you for the region that's down here. I'm going to shade it for you. All of this region right here. What percentage do you know?
16.
Yeah, so it's going to be 68 plus 16%. So it's all of this region right here. And that should give you some number. 84? Do the maths. Should be 84. So 84% lies below 1 standard deviation. You get it? Yeah? Alright, the next question.
Above 85.
Above 85, so 3. So above 85%. So 85% is your 2 standard deviation. And we were doing this earlier. I'm going to erase right here. So 2 standard deviation would be the 95%. Alright? But on previous page we said that both shares should be equal. So if everything is 100 and you only have 95 here, what's missing to give you 100? 5%. So to get equal amount on either side, let's say 5 divide by 2 to give you 2.5. So 2.5 is going to be down here, and 2.5 is going to be above that. So above 85 is going to be 2.5% of the data. And if you add them, you say 2.5 plus 95 plus 2.5 should give you 100%. Alright, so let's see what I'm missing. That's not the big one. Okay, so we're here. Alright, so this one is the one that I also have. So let's get that page. So the average reading speed, are you there? Okay, of students completing a speed reading course is 450 words per minute. If the standard deviation is 70, find the Z-score associated with each of the following reading speeds. You have to show you're working a total of 6 points. So Z-score, you first need to know what the formula is. Yes, you first need to know what the formula is. So the Z-score formula, Z is equal to data value minus the mean divided by standard deviation. So you need to know the data value, you need to know the mean, and you need to know the standard deviation. What did the question give you?
450 words per minute.
So what's this 450 representing?
The mean.
The mean, very good. So the X bar is that. What else?
A deep standard deviation.
standard deviation is 70. So that means this 320 would be what? Hmm? The data value. So this 320, this 474, and this 610 would be your data value. So this WPM should be over the other side. But I think I gave you too many space.
I know, it's on the paper. So.
Okay. Alright, so that's X, and that's X. So let's go ahead and find the Z-scores for all of them. So we know the formula, we basically plug what we know into the formula. So X, so it's 320 minus the mean, which is 450, divided by the standard deviation, which is 70. And this one, same thing. So it's the data value minus the mean, divided by the standard deviation, data value minus the mean, divided by the standard deviation. Which one? You missed a quiz? Which one? That means you missed the Z-score quiz. Hold on. I have papers like almost everywhere, as you guys can see.
You do.
Oh my god. I don't know what's wrong with me, you know. Maybe I have a paper issue. I like your outfit today.
Oh,
You have the girls that said were something similar yesterday, like a planet, something.
Who?
I don't know their name. Okay, I know their name. I don't know their names.
Todd?
And the other, and Frost.
Oh.
Yeah, both of them. You have your
What?
Chromebook?
Oh, you want me?
Yes, I want it.
I'll do it on my
I need that too. I need to build that the A word. I'll go something. Alright, you ready?
No.
No? Alright, yeah. Okay.
I try to do it, but I'm not doing it right.
Did you say 320 minus 450?
Mm-hmm.
Answer equal, then divide by 70? What you got?
-1.
Okay, that sounds like it. I'm gonna explain to you why. I need a. Where did I put my thing? I don't know. So
The
let's break
first
it
time
down.
I did it all together, and then
So you did subtract first and then you divide after.
well, like I did it all together, and then it came out weird. So then I did it separately.
Came out weird.
Like I did it like that,
Oh, that's not right.
and then I did it like that.
Okay, because what
Yeah,
your calculator did first was to divide by 70, then it subtracted.
So I did it right the second time.
So the last time is right, yeah. Ooh, my computer needs to restart. What time is it?
It's
9:30.
Okay, let's restart in an hour.
Let's start our class.
Yeah, but I'm gonna do it before the hour comes. Like, I always have that issue restarting my computer. I don't know what's wrong with me. So what's the answer you got?
-1.857.
That?
Mm-hmm.
Okay, let me explain this to you. So you see, because your mean, I'm gonna give you a diagram. So because your mean is 450 and this number is 320, your data value, that means that this person performed below the mean. So it is below the mean, which is on the negative section. Ooh, okay. The negative section, I'm sorry. I always do that. The negative section of your bell curve, that means your z value is going to be negative. Because in these regions, all the z values are negative. So 320 is below 450, less than 450. Yes. So it's gonna be somewhere down here. Oh, 1 point something you said? So let's fix it. So 1 point something will be somewhere. So 320 somewhere down here. So it should give you a negative z-score. Okay? Unlike those, they are above 450, so there should be a positive number at the end. You can always keep that in the back of your mind to know if your answers are correct or not. Similar to what you said on your calculator, that the number looked weird, so it couldn't be it. So something like that. Always think about it like that, and you should It should help you somewhat.
Parallel slopes.
Alright. That was this morning.
When did we learn that?
No, that's my geometry class. Alright, so Z, alright, let's do this one. So it's 474. You can write after. 474 minus 70.
Oh.
Minus 450. Thank you. And then put the equal sign, then divide that by 70.
Wait, let me join on my phone.
0.342.
3, so 0.342.
Yeah.
So 0, here you need 0.342. Okay. The next one says 610 minus 450 divided by 70.
Uh, 2.285.
So it's Z is equal to 2.285. Alright, very good. So the questions that lies below says identify the word per minute that fell below the mean. So there are two ways to do this. You can put your Z-score or you can put your actual data value. So the one that went below the mean is the one that's negative, as I showed you just now. So the one that went below the mean would be the
320.
320. Answer this one for me.
Would it be 474?
Says identify the word per minute with the highest Z-score.
Oh, mine's different.
Yeah, I know, but for this one, do this one first. With the highest Z-score?
610.
610. So could you read one that you have for me?
Identify the words per minute that would be considered unusual.
Unusual. So for something to be considered unusual, y'all see that?
Why'd you do that?
I don't, it always happens because I have too many things open. So for it to be considered unusual, or some people would say abnormal, you will realize that it falls outside of -2 and +2. So anything that goes outside of this is considered to be unusual. So if 2 is right here, -2 is right here, anything that comes out of here is considered to be unusual. So look at the Z-score that falls outside of, is bigger than 2 and or smaller than -2, and put that for your answer.
Well, there's 474 and 320.
Z-score, the actual value. So 474 came out to be -0. So 474 had a Z-score of 0.3 something, right?
Yeah, 0.3.
And 610 had a Z-score of what?
-185.
No, 610. 2 point something.
2.285.
Yeah. So in that case, which of them is bigger than 2?
610.
610. So that's going to be considered to be unusual. Or some would say abnormal.
Wait, what's unusual?
Unusual is when the Z value falls outside of -2 and +2. So it's bigger than that.
Oh, okay. So
And
abnormal and unusual is the
same word. So some people use it interchangeably. So in chapter 16 or 17, if we get to that point, you guys will learn about the 95% confidence interval. So when people are talking, they normally say, I'm 95% sure that. And so once it's 95 would be these two, right? So once they are sure, they could say that they're 95% sure. But it's very small chance that a person would say I'm 100% sure, which is unusual or abnormal. So in chapter 16 or 17, you guys learn about that. But right now, we are at chapter 6, so we have a good way to go. Hopefully we can get there. If not, we just don't learn it. Alright. Any more questions?
No, not yet.
So,
Look at this. I'm taking this too.
for the back regions, you're going to basically draw a bell curve, find the standard deviation. This girl. So you're going to find your mean, standard deviation, draw a bell curve, and observe the 68. The 95. And the 99.7% rule to answer those two questions. Maybe the last one's gonna be a bit different. We're gonna have to find the actual score, but you should know how to do that one. If not, just ask me a simple question and I'll get to you.
I have a question.
Yes.
Am I finding my Z-score?
Just draw the bell curve. So find your mean, standard deviation, add to your right, subtract to your left.
So I start with 77.
That's the middle. I am on slow motion. Why? Yeah, to do the same thing going that way. Right. Alright guys, that's the end of the video / live stream. I'll get to you guys in another minute.